Hello students, in this video I am going to explain gravitation, okay, which is one of the very important topic CBSE 9. Okay, what are the topics we are going to cover under this? As you see, we are going to cover universal law of gravitation. Universal law of gravitation. This law was given by Newton. According to this law, assume there are two bodies. Let's say the mass is m1, mass is m2, and distance between these two bodies, let's say it is capital R. So what Newton's told, it was given by Newton's only. Newton. It's also called Newton's law of gravitation. What he told there exists a force between the two bodies in the universe. That force F is directly proportional to the product of their masses. Okay. It means if the masses are more, force is more. And it is also inversely proportional to the square of distance between them. Okay, means if distance is more, force is less. Okay, these are the two statements he told. What he told? There exists a force between the two bodies, any two bodies in the universe. That force is directly proportional to the product of masses and inversely proportional to the square of distance between them. Once you combine these two statements, you can write F directly proportional to m1, m2 divided by r square. Is it clear? Once you remove the proportionality, you have to put a constant. So capital G is the constant, m1, m2 divided by r square. Okay, this capital G is called as universal gravitational constant. Universal gravitational constant. Okay, once you talk about the unit of G, see children, G we can write a F into R square divided by M1, M2. We can write a F into R square divided by M1 into M2. What will be the SI unit of force? That is Newton, right? Distance square, that is meter square, and it is kg into kg. So from here we can write the value of G is what? 6.67 into 10 to the power minus 11. Unit we can write Newton meter square per kg square. Newton meter square per kg square. This is very, very important. Next, we talk about acceleration due to gravity. Acceleration due to gravity. See, it is the acceleration produced in the body whenever it is falling freely, okay, under the gravitational force. See, Earth is there. Let's take a radius of Earth is R. R is what? Radius of Earth. Radius of Earth is approximately 6,400 kilometers. Okay. Assume that any body of mass m is there on the surface of Earth. So it is attracted by a force, okay, towards the center of the Earth. That is weight. Weight is equal to what? Mg. SI unit of weight is what? Newton. Weight is a force with which any body is attracted towards the center of the Earth. Now assume that mass of the Earth is capital M. So there exists a force between the body and the Earth. What is that force? F is equal to, according to Newton's law, capital G, capital M, small m by distance square. That is R square. See children, this weight, okay, of the body on the surface of the Earth is due to the gravitational force by the Earth. So we can equate this to, okay, so equation 2 is equal to equation 1 when you do. So we can write mg is equal to capital G, capital M, small m by R square. Do you agree with me? So small m get cancelled. So we can write Small g is equal to capital G, capital M by R square. This is the relationship between small g and capital G, where small g is what? Acceleration due to gravity, small g, and capital G is what? Universal gravitational constant. We can get the value of small g, that is acceleration due to gravity. Okay. Also, how? See, we know the value of capital G, right? Capital G is how much? 6.67 into 10 to the power minus 11 Newton meter square per kg square, correct? Now, mass of the earth is also known. Mass of the earth is what? 6 into 10 to the power 24 kg, right? And radius of earth how much? Radius of earth is 6,400 kilometer, right? Radius of earth R is what? 6,400 kilometer. If you want to convert into meters, we can write 6.4 into 10 to the power 6 meter. How it is? 1 kilometer is how much? 1,000. So 1,000 into this, we can write 6.4 into 10 power 3. So it becomes 6.4 into 10 power 6 meter. Yes or no? If you substitute the value of capital G, capital M, and R square, so we'll get the small g value is equal to 9.8 meter per second square. Is it clear? So this is the relation between the small g and capital G. Okay. See, this g is not going to be fixed. It changes, children. Okay. It changes with height. It changes with depth. It changes with the latitude. Okay. It also changes with the shape of the earth. So I am going to give you the expression of variation of g. Variation of g. Okay. Acceleration due to gravity changes. Okay. First with height or altitude. With height or altitude. How it changes? The expression you remember, GH is equal to G times of 1 minus 2H by R. This is the expression. 1 minus something is what? Less than 1, right? So we can see from this expression, if height increases, okay, radius of the earth, sorry, acceleration due to gravity decreases. Okay, generally children, on moon, you have to remember, acceleration due to gravity, G dash is how much? 1 by 6 times of G. Okay, so obviously that weight also decreases on the moon. Yes or no? So this is one expression that you should know. Okay, variation of G with height or altitude. The GH is what? G times of 1 minus 2H by R. See, this is valid when height of the height from the surface of Earth is far less than radius. Then only. Second is what? With depth. With depth. It means if you go towards the center of the earth, okay, here towards this side, D. Okay, so again, the acceleration due to gravity decreases. What is the expression? Acceleration due to gravity at some depth is equal to G times of 1 minus D by R. This you have to remember here. From this expression also we can say that if the depth towards the center of the earth increases, radius of the, acceleration due to gravity decreases. Is it clear? And with latitude. Third variation is what? With latitude. With latitude. See, suppose this is the earth. Okay, this is the equator. This is no equatorial plane. And what is this? This is pole, right? This is pole. Pole. So here, this angle, if you see different, okay, this angle made by this line, okay, any point on the surface of the earth with the equator, this is called as latitude. Let's say it is theta. So G at theta is equal to G minus R omega square cos square theta. Okay. So see at equator, what is that angle theta? At equator, theta is equal to 0 degree, right? As the theta is equal to 0 degree, so what is the value of cos 0? Cos 0 is equal to 1. So we can write G at equator is nothing but G minus R omega square. Cos theta is cos 0, 1. So 1 square is what? 1 only. Okay, whereas at poles, when you see at poles, this point you see. What is the theta? Theta is equal to 90 degree. So what is cos 90? Cos 90 is equal to how much? 0. Yes or no? So this is the expression cos square theta. So cos 90, 0. 0 into anything is what? 0. So G at a pole is equal to G minus R omega square into cos square 90 at poles. So this term is 0. So this term will get vanished. So it is equal to G only. G at poles is G. Is it clear? Okay, when you should know with shape it changes children. Okay, variation of G with shape. With shape. Okay, see the earth shape is not perfect as sphere. What happens? Radius of equator is more than the radius of pole. You should know this. Radius of equator is more than radius of pole. How many kilometers? Approximately 21 kilometer. Approximately radius of equator is a 21 kilometer more. Okay, plus radius of pole. Okay, radius of equator is more. So as we know that expression, small g is equal to what? Capital G, capital M by R square. See, capital G is constant, capital M is constant, right? That is acceleration, universal gravitational constant is there, that is constant. Mass of the earth is constant. From here, what we can derive? G is inversely proportional to R square. It means if radius is more, acceleration due to gravity is less, right now. So as the radius of equator is more than radius of pole, so acceleration due to gravity at equator is less than acceleration due to gravity at poles. So this is the variation of G with the shape of the earth. Okay, children, if you like my teaching, then you can share with your friends, and please do not forget to subscribe the channel. This is Sandeep sir here. Thank you. The next video we will discuss about the derivation, how this G we got. Okay, with height, with depth. Is it clear?